I will calculate the flux. Again, Faraday's law. So E is minus d phi by dt. Inductance 1 into 10 power minus 3 Henry. Now comes the problem on mutual induction. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing my session, today we will focus on the problems appearing from the chapter Electromagnetic Induction. In the previous 3 sessions, I have worked out problems from the chapter Alternating Current. They are all 5 markers which is asked from the previous exams. And today I will be concentrating on the problems from electromagnetic induction. And these are the problems which are asked for 2 marks in the previous exam. The first one. The problem says the magnetic flux, the magnetic flux threading a coil. A slightly upgraded word is used here. Threading andre associated anta artha. So associated with a coil anta helaಬಹುದು. So the magnetic flux threading a coil changes from 10 into 10 power minus 3 Weber to 2 into 10 power minus 3 Weber. So the initial magnetic flux linked with the coil, initial magnetic flux associated with the coil is 10 milliweber, and the final magnetic flux is 2 milliweber in 0.01 seconds. I have to calculate the induced EMF. So as we usually do, the first part of the solution is to collect the data, analyze the question. So the data says initial magnetic flux linked with the coil. I call that as phi 1, which is 10 into 10 minus 3 Weber magnetic flux. And the final magnetic flux is 2 into 10 power minus 3 Weber. This change is happening in 0.01 second. So dt is equal to 0.01 second. I have to calculate the induced EMF. So on one side, I have collected the known quantities. The other side, now I know what has to be calculated, induced EMF. How will I relate them now? Yes, Mr. Faraday is coming to our help. So we know from Faraday's laws, E is minus d phi by dt. On substitution, E equals minus. So this is phi 2 minus phi 1 divided by dt. So d phi, change in magnetic flux. So change in magnetic flux na yav reeti baribahudu? Final magnetic flux minus initial magnetic flux. Phi 2 minus phi 1 divided by dt, or E is minus 2 minus 10. 10 power minus 3 is common milliweber salitu divided by dt. So how much is dt? 0.01. So dt is 0.01. So E equals 2 minus 10 is minus 8. I don't require a supercomputer to do that. 2 minus 10 is minus 8. There is a minus here, so it becomes 8. So now 8 divided by 0.01 is 800. So 800 into 10 power minus 3, or E equals 0.8 volts. So using Faraday's laws, substitution, simple simplification, E turns out to be 0.8 volt. Second one, again, the one which is associated with Faraday's laws. The magnetic flux. Again, we talk about magnetic flux linked with the coil varies according to the expression phi equals 3t square plus 4t plus 9. So the magnetic flux associated or linked with the coil is changing according to this equation. What is the magnitude of the EMF induced when time t equals 2 seconds? I have to calculate the induced EMF when time t equals 2 seconds. And remember, this was a question that is asked in a CET paper. Now, the problem says phi equals 3t square plus 4t plus 9. So the flux linked with the coil, associated with the coil, changes as phi equals 3t square plus 4t plus 9. I have to find out this flux when the time is 2 seconds. So for first, I will calculate the flux. Again, Faraday's law. So E is minus d phi by dt. So I have E is minus. So this is 60 plus 4. A very simple differentiation. 60 plus 4. Now, when t is equal to 2 seconds, this is where I have to calculate the flux specifically. When t is equal to 2 seconds, E equals minus 6 into 2 plus 4. That is minus 6 into 2, 12, plus 4, 16. So minus 16 volts is the answer. So this is the EMF induced when the time is 2 seconds. See, ಎಷ್ಟು ಸುಲಭವಾಗಿದೆ. Simple expression. ಸ್ವಲ್ಪ ಒಂದು differentiation knowledge, you will arrive at the answer. Next one. These type of questions are commonly asked. Now, what EMF will be induced in a 0.5 Henry inductor? The value of inductance ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. What EMF will be induced in a 0.5 Henry inductor in which current changes from 10 ampere to 7 ampere. Initial current flowing in the inductor is 10 ampere. Final current is 7 ampere in a time interval of 0.05 seconds. Again, so here the value of inductance is given 0.5 Henry. L, inductance value 0.5 Henry. Current I1 is 10 ampere and I2 is 7 ampere. I1 is 10 ampere, I2 is 7 ampere, and dt is 0.05 seconds. In this case, how will I calculate the induced EMF? Do I know any relationship relating EMF and inductance? Good. So we know E is minus L di by dt. ನೋಡಿ ಎಷ್ಟು ಸುಲಭವಾಗಿದೆ. E equals minus L di by dt. Now on substitution, this can be written as minus L I2 minus I1 by dt. So di change in current now. I2 minus I1 by dt. L is 0.5. So E is minus 0.5. 7 minus 10 divided by dt is 0.05. So this is 0.05. So E equals 7 minus 10 minus 3. Minus into minus becomes plus. So 0.5 into 3 is 1.5 divided by 0.05. The answer is 30 volts. So in this case, the EMF induced is 30 volts. See, very simple. Just know the expression. Simple substitutions. Use your calculators. You will arrive at the result. Next one. Current in an inductance of 1 millihenry. Now it is 1 millihenry is reduced from 5 milliamps to 0. Now the initial current is 5 milliamps. Final current is 0 in 1 millisecond. So inductance is also in terms of milli. 1 millihenry. And the time interval is also 1 millisecond. Again, find the EMF induced. So again, inductance 1 into 10 power minus 3 Henry. Millihenry 1 into 10 power minus 3. I1 is 5 into 10 power minus 3 ampere and I2 is 0. And this happens dt in 1 millisecond. We have to find the EMF induced. The same problem as we did in the previous case, but here some powers are given. Millihenry, milliseconds. Now, again the same way, E is minus L di by dt, or E is minus L I2 minus I1 by dt. Now on substitution, E is minus 1 into 10 power minus 3. This is 0 minus 5 divided by dt. 1 millisecond, 1 into 10 power minus 3, again here 10 power minus 3. So when we simplify, the answer turns out to be 5 millivolts. So very simple on simplification. This is minus again, minus becomes plus, 1 minus 3 goes, so 5 divided by 1 millivolts. Fifth one, this is very important now. The problem says, what is the self-inductance? Induced EMF alla iga. Self-inductance. You have to calculate L. What is the self-inductance of a solenoid? Very important data. Self-inductance of a solenoid of length 0.5 meters. Length of the solenoid is given, which is 0.5 meter. Area of cross section is given 0.05 square meters, and total number of turns is 1000. Analyze Madi. The solenoid is having a length 0.5 meter. Area of cross section 0.05 square meter. Total number of turns 1000. So if you collect the data here, length is 0.5 meter. Area of cross section 0.05 square meter, and capital N, total number of turns is 1000. To begin with, first I will calculate turns per unit length of the solenoid. Yavaglo analyze ಮಾಡಬೇಕಾದ್ರೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, you are first calculating turns per unit length, that is small n, which is equal to capital N divided by L. Turns per unit length, which is 1000 divided by 0.5. When you simplify, the answer is 2000. So first, you have calculated turns per unit length, which is 1000 divided by 0.5. So you have 2000. Now, what is the expression for self-inductance of a solenoid? Mu naught n square A into L. So this is the expression for self-inductance of a solenoid. 2018, there was a 1-mark question. How is the self-inductance of a solenoid related to the number of turns per unit length? And the answer is proportional to square of n. So on substitution, mu naught is 4 pi into 10 power minus 7. into n square. I write this as 2 into 10 power 3 whole square, 0.05 into 0.5. So when we substitute, so this is 4 into 3.14 into 4 into 0.05 into 0.5. So this is, again, we will cross-check the simplification. 4 into 3.14 into 4 into 0.05 into 0.5, which is 1.256 into 10 power minus 1, or 0.1256 Henry. So this is the value of the self-inductance. Sixth one, when the current through primary decreases from 2.5 amps to 2 amps in 0.1 seconds, the EMF induced in the secondary is 3 volts. Calculate the coefficient of mutual induction. Now comes the problem on mutual induction. The same way ಅಲ್ಲಿ self-inductance ಕಲಿತಿದ್ವಿ, ಇಲ್ಲಿ mutual inductance. So again, E is minus M into di by dt, where M is called coefficient of self-mutual induction, or E equals minus M I2 minus I1 by dt. Exactly the same way as we have done the previous problems. So now E is 3 volts minus M. So I1 is 2.5, I2 is 2, time interval is 0.1. So this is 2 minus 2.5, 0.1, or 3 equals minus M, 2 minus 2.5, 0.5. So 0.5 divided by 0.1 is 5. So this becomes plus. So M is 3 divided by 5. So 0.6 Henry is the answer. See, all these problems, they are very simple. Just know some equations, you can work out. The same way, this is an assignment for y'all. The same as I did the previous problem, to calculate mutual inductance of the 2 coils. A AC generator consists of 500 turns, each of area 0.01 square meter, rotating at an angular speed of 300 rotations per minute in a uniform magnetic field of 2 Tesla. Find the peak and the RMS value of EMF induced in the coil. This again, I'll give you all the hint you will substitute. Peak value of induced EMF, N, A, B, omega. Directly number of turns is given, area of cross section is given, magnetic field is given, but omega is in terms of minutes. You will have to convert it into seconds divided by 60. So many volts will be the answer. So dear students, you saw how easy for 2 marks problems from this chapter appears. In the next session, I'll take up 5 marks problems from this chapter. Until then, have a nice time. Thank you.